All right. So what we're doing today is multiplying a polynomial by a mononomial. We are also going to try to get to factoring. So we're also going to try to get to factoring.
Oh no.
Great nose.
Kane will annoy the heck out of you with this.
Okay, here we go. So we're going to multiply a polynomial by a mononomial. So mononomial is one term, a polynomial is a single term. Let's just try a really simple one. Let's say I have negative 8 times 2y plus 1. How would you do that?
You distribute.
We distribute and we take the sign with the number. And what do we get?
Negative 16y.
Then?
Minus
8.
Minus 8. And there's our answer. Okay, there's nothing else that we could do. So the only thing that we're going to add to the mix today is what if I had a variable on top of that? So what if I had 3x cubed y, and then I multiply that times this?
I forgot how to factor, Kane.
Okay, well you'll remember shortly. Okay, so we're going to multiply this one. Now, before we get to the actual multiplication, let's just up here kind of recall a little bit of rules of exponents. So if I had x cubed times x, what would I get? X to the fourth. I add my exponents, and if it's not written, this is a 1. And if I had x cubed y times xy squared, what would I get?
x4, y3.
Yes, we add each of the exponents on things. So that is going to be the only new thing that we're going to add to this process. So we distribute this to every single term, but now, because we know the rules of exponents, we can actually deal with the exponents. So I multiplied the coefficients. Now the coefficients are the numbers in front. So 3 times 5 is?
15.
And then I do the x's and the y's, so x to the
4.
y to the
3.
Okay, and then the next one, I multiply 3 and negative 7 and get
Negative 21.
negative 21, and then I do my exponents. X to the third times x squared is x.
5.
And then if I do y times y, that is
y2.
y squared. And then we get plus 12, x to the 4, y squared. Does anyone not follow what we just did there to multiply that? Pop your hand up if you got it. Like, Mr. Cage, shut up. I don't have to do this.
Please shut up.
Okay, she just wants me to shut up because she hates my voice. We'll do then just 2 examples of that, and then we'll go on to the factory. Okay, so let's say I'll go back in a moment. You guys said that you got it, so I'm going to trust that you do. And if you understand these 2 examples, then you should be, whether you got the first example or not, really does not matter. Alright, so we're going to combine a few different things that we've learned. We're going to do rules of exponents. We are going to do combining like terms. Okay? So what do you think you need to do first? Go ahead, Trey.
Distribute.
We're going to distribute. Okay, so I distribute a y. What do I get on the first thing?
y2.
You get
Y squared.
plus 3y.
Anyone lost on that? Now the tricky thing here is I need to take this negative with this 5. Okay, when I distribute that, what do I get? Meredith, first term.
Negative 5 y squared.
Good. And the second term, Taylor.
Positive 10 y2.
Not y squared, just y. Because there's no y right here.
Yeah.
Okay? Alright, now we're going to combine like terms. Okay, so I have y squared and negative 5 y squared, so that gives me negative 4y squared. And then I have 3y plus 10y, which is 13y. Final answer. Are those like terms? Could I combine those?
No.
No. Okay. This is, by the way, this is a binomial of what degree?
2.
2. Okay, a binomial of degree 2. All right, the second example up here. I will distribute. So I distribute. What do I get, Rachel?
You would get 12x to the third. Why have you done that?
Huh?
You put 14.
Because I'm dumb.
You're a punk.
Good catch. 12x cubed, right? And then continue, Rachel.
Minus 16x squared.
Okay. And then next thing, what do I distribute? Ryan?
You distribute negative x,
And get?
negative 7x squared.
Okay. Now we combine like terms. I wouldn't call this a trinomial. I don't classify until I'm done. So we get negative 23x squared. And that's our final answer. Any questions how to do this?
Can you get rid of the last line?
Yeah, real quick. I'm not going to stay there too long.
Oh, but why didn't we solve it?
Are there any like terms?
Yeah.
Wait, can't you add them?
15x4 and 12x4.
Nope.
Oh, wait,
What's
no,
a
you have the
y?
lies on
This is
them.
y cubed and that's y squared. Those don't like terms. So none of those were like.
You can't add. Oh, heck, you forgot.
Okay. I want you to try 2 examples on your own in your notes. Okay? Oh, I don't want that. Okay, here we go. So do these 2 in your notes. Okay, try both of those.
Wow. Kane, does anybody like you?
Is that from Star Trek?
Really? Did you just say that?
I know.
Okay, first one.
You just wrote it down.
It's been up there for like 10 minutes.
Mr. Kane.
Sarah's like, your concept of time, Mr. Kane, is greatly distorted.
I
That
literally
is
forgot
from
to say
Lego
that.
Star Trek, boys.
Okay, anyways. I'll give you one more minute. Wrap them up.
No, that person.
Wrap them up, wrap.
No.
I love that animated film.
Jar Trey. The ugly one.
Just draws a circle.
Perfect. Oof.
Who's that?
It's you. You show ugly self. Yes. Yes. Yes.
Okay, first one. What do we do, Kaylee?
We distribute.
Okay, what do we get?
Hold on, why do I have a beard? I have nothing.
That's a double check.
That's your team. Okay, anyways, Kaylee.
8x squared.
Nope. What do we do with the exponents, class?
You
Add them. 8x to the 4th. Continue, Ryan.
And that would be 12
Minus 12.
minus 12 cubed, x cubed.
And final term is, class?
Plus 21.
28 what?
X2.
squared.
No,
Right,
that
right.
looks more like Daniel.
Okay.
No, okay, whatever. All right, going on. Next one. Meredith, what do we do?
You distribute.
Okay, so we have two things to distribute. What do we get in the first group, Rachel?
You get 4x cubed minus 12x squared.
And the next group, now I don't switch to multiplication or anything, I am multiplying, but what do I get? Brian.
Minus 10x squared.
And then what?
Plus 6.
Careful.
12. X. My bad.
And then finally we combine like terms, we only have two like terms. So we have 4x cubed minus 22x squared plus 12x. Okay, final answer there. Final answer there. Last chance. Any questions on doing this multiplication? No. Once, twice,
Crap.
sold. Next topic for today, factoring.
No.
So factoring is perhaps one of the more important things that we will do this year. And yes, Trey's right. I'm going to bother you about it pretty much the rest of the year. Because
If you don't know how to factor, you're going nowhere.
yep, that's nowhere in math class anyway. Because factoring basically never goes away. All right, here we go. So what we're going to do is we're going to factor the common monomial. And this is the first step of all factoring questions or anything that involves it. You have to check for this first. If you forget this, then you're going to do it wrong. So you need to check it. So let's take a look. Let's do an easy example. Let's have 5x plus 7xy. Okay? And what I'm going to look at each term. And I'm going to look for what's common. What do they both have?
X.
And in this case, they both have an x. Okay? So, for that thing, I'm basically going to divide each of those terms by the common thing. So, when I do that, now I said what was common. I said, okay, what was common?
X.
X. So I'm going to put the x on the outside, because that's the common thing, and now I'm going to basically divide each of those terms by x, because I essentially pulled that x out. Okay? That leaves, now 5x divided by x is 5, and then if I pull out an x from here, 7xy, that leaves 7y. So a way to check to see that I've done this right, and I'll put it right here, is what if I distributed that x back in? If I went back, I multiplied it in, I get 5x plus 7xy. Okay, now we'll do a few more examples of this, but basically I'm taking the thing that's common and pulling it out and putting it on the outside. This thing that's on the outside is called the greatest common factor. Okay, sometimes you're just asked what is the greatest common factor, and then you just write x. But if you're asked to actually factor, then you write this whole thing. So this whole thing is, I'll get your question in a moment, because I have a feeling it's not about what I just talked about.
It's not.
Okay, so that's our answer. All right, let's do another example.
Real quick.
Hurry up.
Okay, so it says 6 through 54 odd. Why do you put 6 through 54 instead of
Okay,
like
don't worry
7 through
about that.
55?
Okay.
You stop breathing.
We look at Sarah. That's not. Okay. Let's look at all these terms. We're going to factor. I'm going to look for what's common. I'll look at all the numbers. Don't forget the numbers. Is there something common, a common factor of all the numbers, Sarah?
Multiples of 5.
5. So I'm going to take out a 5. Okay? Now let's look at the x's. Now I have an x cubed, an x squared, and a single x. Now I can take out more x's than I have. I can take out only one x. I can't take out 3 of them because this term over here only has 1. All right, the next one, I look at the y's. And how many y's could I take out?
1.
Just 1. Because this one has 1, that one has 4, that one has 1. So the most I could take out is 1 of them. Alright, so now I'm going to ask. Now this thing in front, that's my greatest common factor. Okay, so sometimes like in your homework, it's just asked, what is the greatest common factor? And that is your answer. That's all you would write. Right here, though, if I'm asked the factor, I have to write this whole thing that I'm about to write. So what's 5 divided by 5? 1. Okay. And then what's x cubed divided by x? Well, how many x's did I take out? 1, which leaves how many left? 2. So that's x squared. And then I took away one of the y's. That leaves how many y's? None. There are no y's left. Okay. 15 divided by 5 is how much?
3.
See how I'm dividing each thing? And x squared divided by x is?
X.
And then y to the 4th divided by y is?
3.
Y to the 3rd. And then 20 divided by 5 is?
4.
And then both of those are taken out. So that's it. And this would be my answer. Now, before we do the next example, keep in mind, what's 6 divided by 6? 1, not 0. Then what is x divided by x?
X.
1.
No, it's what? 1. Okay, y. Let's take a look. What's the exponent here?
1.
What's the exponent here?
1.
Okay, what's 1 minus 1? Because rules of exponents.
0.
And anything to the 0 power is?
1.
1. Okay? What's x squared divided by x squared?
1.
1.
1, right? Anything divided by itself is
1.
1. Okay? So we're going to want to keep that in mind because that's going to be a trick for this next one. Let's say I want to factor 2x squared plus 2. What's common?
2.
2. So I factor out a 2. So that's my greatest common factor. That's my GCF. Then what's left on the inside? X squared. Is that it?
Plus, yeah.
No, that's not it.
No.
There's a reason I mentioned this.
Plus 1.
What's 2 divided by 2?
1.
1. So plus 1. Okay? It's not a 0, because 2 divided by 2 is not 0. Alright, let's factor another one. X cubed plus x squared. Okay, I want to take out as much as possible.
X2.
So I can take out Trey's right, x squared. Does anyone not see why that's x squared? Okay, how many x's are here then?
1.
1.
Plus
1.
1.
1. Because x squared divided x squared is 1. Does anyone have any questions on factoring the common monomial? Okay, then I'm going to give you 2 to try on your own.
Do it.
Try these 2
On whiteboards?
in your notes. By the way, you can start on the first one while writing the second. Just saying. Okay, so we're going to factor.
Yeah, we are.
All right. First one. Look at the numbers. What's common?
2 and x.
Okay, I heard a few answers. 2, right? Not a 3, because 4 and 2 is not divisible by 3. And how many x's could I pull out?
1.
1. So, that's my greatest common factor. If I'm asked for that, that's my answer. But I'm asked the factor, so I need to write the rest. What comes first?
3 x 2 minus 2x minus 1.
Yes, because negative 2 divided 2 is negative 1. Who got that right? Who's confused? If you're confused, speak now. Anyone confused? Okay, next one. What's common?
3.
You get a 3, you get an x, and you get a 2.
X squared. Okay.
Same difference.
And what do I put in here?
2x 6 minus 1 x2 plus 3x. Or no.
None of it. Yep. This is good. Final answer. Who got that one right?
I didn't get to it.
Oh, didn't have time. Okay. Well, you just did, so you got it right. Good. All right. Now, last thing for your notes, and then we're going to do a bunch of practices. I want you to look for the error.
Found it.
Ha 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 ha. Okay? The directions for this were to factor. However, this one is wrong. I want you to think about what's wrong about it. Brian already has a solution. Okay? Ryan, what's wrong about the first one?
There's no y. See?
There's no y?
Yeah.
Why would I need a y?
Because you got a y and a 8. 8y.
I can't factor out a y.
Dang. Never mind.
Okay? The y threw him off. Anyone else have an idea? Why is this factored wrong?
You can't divide. There's no. What? Dang it, never mind.
Well, let's go back. Let's go backwards. Let's distribute. The problem started as 12x squared plus 24xy. Okay, let's factor that. What can I take out?
A 3x.
Okay, well I told you this is wrong. That answer is wrong.
A 4.
I could take out a 4.
You could.
I could take out a 6. Could I take out more?
Yeah, 12.
I could take out a 12. And what else could I take out?
X.
And what would that leave? That'd leave x plus 2y. So what's wrong here? They could have factored out a 4.
Bigger number.
Okay, they could have factored out a 4. You have to factor completely. You have to take the greatest common factor, which means by leaving that extra 4. So that would have been 12 here. So if you do that mistake, you can go back and be like, all right, I could have taken out more, so you do. The next one has a similar problem. What's wrong with the second one? Someone besides Trey.
They could have taken another x.
Yes, we could have taken out another x. So it should have been 2x cubed 2 plus 9y plus 10z. And there is one other problem with the way I wrote that. Okay, it should be 9y plus 10z. Oops.
Wait, why wouldn't 10 go first?
It goes by the variables.
But z comes
Alphabetical.
Alphabetical order by the variable. Okay, and we are done with notes, so put your notes away.
Yeah.